In this video, I want to talk a little bit about when our electrons do not equal our number of protons. So we talked about in a previous video that we had three subatomic particles, right? Our protons, which we said have a positive charge, so +1, and we said that they were found in the nucleus. We had our neutrons, which had no electric charge. Those were also found in the nucleus. And then we also had electrons. And our electrons had a -1 electron charge, and they were found outside of the nucleus. And in chapter 3, we will spend a fair amount of time looking at where exactly outside the nucleus they're located, but for now, outside is fine. We talked about our atomic number. We said our atomic number was the number of protons in an atom's nucleus, and the number of protons define an atom as belonging to a particular element. So all atoms of the same element have the same number of protons. Neutrons, we said, can vary for atoms of the same element, and that gave us isotopes. So remember, isotopes are atoms of the same element, but with different mass numbers. So they're going to have the same number of protons, right? Because they're atoms of the same element, and they wouldn't be if the number of protons were different. So same number of protons, but they have a different number of neutrons. And we can use hydrogen as our example. The most common isotope of hydrogen is hydrogen 1, but hydrogen 2 does exist. And then hydrogen 3 in very, very trace amounts. But all three of those would be isotopes, right? They all have one proton. If we were to find hydrogen on the periodic table, its atomic number is 1. If I was to include it, I would put it down here. And as I said, I normally don't because it wouldn't be an H if it wasn't 1, right? The only way we can write the atomic symbol for hydrogen is if it has one proton. My mass number then, the numbers I have written as superscripts in blue, right, are my mass number, so the number of protons plus neutrons. So our most common isotope of hydrogen has no neutrons, right? 1 minus 1 is 0. Hydrogen 2 is deuterium. It has 1 neutron. 2 minus 1 is 1. And then tritium has 2 neutrons. So these would be isotopes of each other, right? Same number of protons, right? That number is the same, but a different number of neutrons. What I want to focus on in this in this video are ions. And ions are going to be charged atoms. Do not get isotopes and ions confused. They both start with I, and it's really easy to do it. But these are going to be charged atoms. Remember we said if our atom was uncharged, right, our number of electrons, those were our negative charges, must equal my number of protons, those are the ones with the positive charge. So if my atom is going to be electrically neutral, right, if we go back up, my number of electrons have to equal my number of protons. Remember, neutrons don't have a charge. So the only way for my atom to have a net charge of 0 is if those two numbers are equal to each other. To make them charged, we're going to vary the number of electrons. Remember, again, we can't change the number of protons. If we do, we're actually getting a different type of atom entirely. So these are going to be atoms in which the number of electrons does not equal the number of protons. So our charged atoms. And we can get ions in two different ways. We can lose electrons or we can gain electrons. So our positively charged ions, right? If they have a positive charge, their number of protons are going to be greater than our number of electrons, which means it has lost electrons. Be really careful when folks are first learning this, and we'll put the negative right next to it so we can compare and contrast. they'll get these two mixed up. We want to remember that electrons are negatively charged. So if something is going to be negative, right, it's going to have to gain electrons. If something is going to be positive, and by something I mean the atom, if it's going to be positive, then it has to lose electrons. So if I have a negatively charged ion, and we should actually write these, so the electrons are the one we're varying, sorry. So positive, my number of electrons is less. Same thing I had written before, I just wrote it backwards. Right, I put the proton on the neutron on the right instead of the left. So if it's negative, it gained electrons. So my number of electrons are greater than my number of protons. Remember, it's the electrons that we're changing, so that's why I switched that one around. So the electrons are the one we're focusing on. So if it lost electrons, it has less. If it is negatively charged, right, it gained electrons, it has more. So gained electrons. And again, just be careful with this. When folks are first learning it, and I know you guys have had chemistry before, so this isn't completely foreign to you, but it's still easy to goof it up, right? We see something that has a negative charge and we think, okay, it's negative, it's lost. It hasn't, it's gained. So negatively charged ions gain electrons, right? The number of negatives are greater than the number of positives. Positively charged ions have lost electrons. So just be careful for that. We do have special names for these. A positively charged ion is called a cation. And I just remember that cats are positive. I like cats. If you don't like cats, you can remember that Jen thinks cats are positive. So cations are positively charged ions, right? They're atoms that have lost electrons. And then anions, that's an A, are negatively charged ions. They're atoms that have gained electrons. So if it's positive, it's lost electrons and its name is a cation. If it has a negative charge, it's gained electrons and its name is an anion. Or you could say negatively charged ion. So what I want to do is just make a quick table like we did before, where we had the number of protons, number of neutrons, number of electrons, mass number, and atomic number, and then we fill it out. But this time, instead of having all neutral atoms, right, all atoms that have no net charge, we're going to have some ions, so atoms with charges. So we'll do my atomic symbol. And we're going to do it with the charge. I know I haven't shown you how to do it yet, but we will. And then we're going to have our number of protons. This is probably in a different order than before, but number of neutrons, number of electrons, atomic number, and then mass number. So our first one I want to do, let's have 15 protons, 16 and 18 electrons. This one will write, so if it has a charge, the charge is going to be written as a superscript after the atomic symbol. And then if the charge is not +1 or -1, like if it's a +1, you can just put a plus sign. If it's a -1, you can put just the negative sign. You don't need the number 1 to go with it. But if it's not 1, if it's +2 or -2, +3, -3, then the number goes before the charge. So just where I have some extra space, I wrote that as copper, and then the 2, and then the plus sign. Copper +2 is actually incorrect. I know it seems nitpicky, but 2+ is the charge. If you write it plus 2, then you're technically referring to its oxidation number, which isn't always the same as the charge. Sometimes it is, so it doesn't matter, but the proper way to do it is to write the number and then the charge. So if it was a -3 charge, you would write 3 and then the negative. We are going to talk about oxidation numbers in chapter 7. So there I'll give something that has a 2 plus charge, and then we'll say the oxidation number is plus 2, and then we know which one's referring to which because of how we write it. So as a superscript, the number first and then plus or minus. So we're going to do copper, and then let's have a mass number of 64. Remember, mass numbers are whole numbers. Let's do an atomic number of 8. Mass number of 15, and we'll have 10 electrons, and then one more. Yeah, I guess that one works. Aluminum. Well, I'm going to do something with a negative. Sorry guys, I'm talking out loud. Let's do nitrogen. It's a 3 minus. And we'll do a mass number of 15. Okay. So this is one where if you want to pause it and fill in the table and then come back, that would be great. Okay, hopefully you did that. If you didn't, that's fine, but I would definitely practice it on your own in the future. So the first one, remember my number of protons is represented by my atomic number, so those two columns are always going to be the same. So if I have 15 protons, my atomic number is going to be 15. My mass number, remember, is my number of protons plus my number of neutrons. So 15 plus 16 is 31. And then to get my symbol, I'm going to find the atomic number of 15 on the periodic table. The symbol that goes with that is P for phosphorus. And then we have to figure out the charge. So remember, my protons are my positive charges. My electrons are my negative charges. So I have 15 positives and 18 negatives. So that means I have 3 more negative charges. So a 3 minus for its charge. Copper. I'm finding copper in the periodic table. Copper has an atomic number of 29. So it has 29 protons. Since copper here has a plus 2 charge, remember if it's positive, it's lost electrons. So it's going to have 27 negative charges, 27 electrons. And then to get the number of protons, we're going to subtract 29 from 64. So I am going to have 35. Did I do the math right? Yeah, 35 neutrons. My third row, I have an atomic number of 8, so that means I have 8 protons. Looking at the periodic table, oxygen is the atom that has 8 protons in its nucleus. I have 10 electrons, so 10 negative charges. I have 8 positive charges, so this is going to have a 2 minus charge, right? It has 2 more negatives than it does positive. And then my neutrons, 15 minus 8 is 7. So 7 neutrons in this isotope. Nitrogen, find nitrogen in the periodic table. Its atomic number is 7. So it has 7 protons. I have a -3 charge, so I have 3 more electrons than I do protons. So that's going to be 10. And then to get the number of neutrons, 15 minus 7 is 8. Please practice these guys if you need to. If you have questions, please be sure to ask.